One really common three-dimensional shape that we haven't talked about yet in Chapter 11, and that is the sphere. So today you're going to learn how to calculate both the surface area and the volume for spheres. The technical definition of a sphere is the set of all points in space equidistant from a given point. You're used to thinking about spheres in terms of just being a ball shape, but really the technical definition of a sphere is the same thing as one of those baubles you find at craft stores. These bauble, the ends of the yarn represent the sets of all points in space equidistant from the center, because all the yarn's the same length. So that's really the technical definition of the sphere, the collection of all the points, the radius, distance, out in all directions from the center. There's a couple other terms you need to be familiar with. Hemisphere means half of a sphere, and a great circle is the largest possible cross-section of a sphere. So, for example, this dotted line here, that's the largest possible cross-section. I'd get smaller circles if I took cross-sections anywhere else. That's a great circle. To calculate the surface area of a sphere, you would use this equation, 4 pi r squared. Here's a quick visual representation of how it works. Notice how 4 pi r squared is really 4 times pi r squared, area of the circle. 4 circle areas. Now, think of the way a baseball or a softball is constructed. Think about what that would look like unraveled. Do you see how that's 4 circles to cover the outside of your ball? In other words, it's 4 pi r squareds of area. So a quick note about calculating surface area. When you plug in your radius into 4 pi r squared, make sure you follow order of operations. Make sure you square the 5 before timesing by 4. Some of you have calculators who do that for you. Some of you have calculators where if you type 4 times 5 squared, it will go in the proper order of operations. But if not, you might have to go the long way. Notice how sometimes you'll have to split your diameter in half before you can plug it in for surface area. Pause here and see if you could figure out the challenge question next on your own. So it's always a good idea to start with a summary of what the problem is telling you and asking you. Here they're telling you the circumference and asking for surface area. So you'd plug in 25 for c in the circumference formula and solve for r. You divide both sides by 2 pi to cancel out the 2 pi in front of the r. And you get something very close to 4. You could use 3.98 or you could just use 4, either way. Because they tell us to turn to the nearest whole number at the final step, you might as well round to now. Now you have your radius and you can plug it into your surface area formula. And you should get something within the ballpark of 200 square inches. Pause here and try question 4 on your own. Go ahead and check your answer. So here they're telling you the surface area this time and asking for diameter. You plug in 1018 for the surface area side of your surface area formula, and you get r squared by itself by dividing both sides by 4 pi. To cancel out the square, you square root both sides of your equation, and you get something fairly close to 9 units long for your radius. Always go back and check and see if you're done. Oh, no, they don't want radius, they want diameter. A diameter is 2 radii, so 2 times 9, 18 inches. Your volume formula for spheres is 4 pi r cubed all over 3. A quick note about plugging that in your calculator. Different calculators have different ways to do exponents. So some of you have an x to the power of y button, so you type the 12 to the power 3 of 12 x to the power of y 3. Some of you have a caret button for powers, 12 caret button 3. And when you simplify, you should get 2,304 pi cubic inches. This is volume, so make sure your units are cubed. Pause here and try question 6 on your own. Go ahead and check your answer on question number 6. Number 7, start by summarizing the information from the problem. They're telling you volume, so you'd plug in 2,200 for the volume side of your formula. And then you would start solving for r cubed and getting r by itself. So you could times both sides by 3. You can divide both sides by 4 pi. And then to get rid of the cube on the r and have just the radius, you need to cube root. That would cancel out the power of 3. Now, typing a cube root on a calculator, some of you have calculators with an actual cube root button, but a lot of you don't. A lot of you have an X root button. That's just a flexible way to type in all sorts of radicals. So what you'll have to do then is type 3, and then second caret, because that will type the X radical symbol, and then the number 525.2. So check that you're getting roughly 8.1 for your radius, a little bit less than that. Once you have your radius, because they're asking for surface area, you'll plug that into your surface area formula. I forgot to specify here whether it was supposed to be left in terms of pi or not, so here's both versions of the answer. Because this is back to surface area, your units are squared. Great job, everybody. Don't forget to turn in a picture of your notes on Schoology when you're done.